Uh, Hello guys, Assalamu alaikum. So today this is our third lecture related to kinetic particle theory. In the initial two lectures we have just given the brief introduction to the syllabus, and I have told you that there are three papers in your examination criteria regarding chemistry. We have done the basics of the kinetic particle theory. Right here today we are just dealing that there are three states of matter. One of them is solid, and then liquid, and then a gas. You can see from the first diagram right now here on this page that when solid is absorbing heat, when we are giving heat energy to a solid, it is converting itself into a liquid, and when we are giving heat energy to the liquid, it is converting itself into a gas. So according to this procedure, we should know this thing that a solid is at the lowest energy level, lowest kinetic energy. When we are providing heat energy to a solid, its kinetic energy, particles are gaining the kinetic energy in solid, and then they are transforming themselves into the liquid. When liquid particles are gaining the heat energy, they are converting themselves into a gas. Reverse process can be occurred as well. What is the reverse process? It means that we are lowering down the heat energy, we are removing the heat energy from a gas. A gas can be converted into the liquid, and when we are removing the heat energy from the liquid, it means that a liquid can be transformed, can be converted into a solid. So this is happening in the three state changes. This is happening when we are going to transform one state into another by changing the temperature, by adding the heat, or by removing the heat. So here we have different processes. In these different processes we are changing one state into another, and these are called as the interconversions of one state of a matter into another state of a matter. Okay, right now the first process is melting. In the melting, basically we have a solid at the start, and the solid is converting itself into a liquid. So what is a melting? Melting is a process in which a solid turns into the liquid state at a fixed temperature. Okay, so it is a plus triangle process. What is the meaning of plus triangle? It means that heat energy is absorbed. And what is the triangle representing? Triangle is representing the heat energy. So plus triangle mean heat energy is absorbed. So it means that melting is a heating process. Okay, reverse of melting, opposite of melting is called freezing. In case of freezing, basically we are turning a liquid into a solid. It is a negative triangle process. It means that it is a cooling process. We are removing the heat energy from the liquid, and it is turning itself into a solid. So hence in this way freezing can be considered as a cooling process. Now I am telling you once again what is the heating process. Heating processes are all those processes in which heat energy is absorbed, whereas cooling processes are those processes in which heat energy is released, heat energy is removed. So we can say this is cooling process, and that is a heating process. Okay, I am taking you to the next page. Okay, so this is related to boiling. In this case, boiling is also one of the change. Boiling is one of the process in which one of the state is converting into another. Guys, boiling is a process in which a liquid is turning itself into a gas. So it is also a plus triangle process. It means that we are heating the process, we are heating in this process, we are heating the whole thing, and it is a heating process. Heat is added into this process. Okay, and a liquid is changing into a gas in the boiling. There is a reverse process of boiling which is called condensation. In condensation, basically a gas is turning into a liquid state back. So we are removing the heat energy from the gas state, and it is turning into the liquid state. We can say this thing that it is a negative triangle process. We are removing the heat energy, so that's why it is considered as a cooling process. Then there is another process called as evaporation. In evaporation, basically it is a heating process. In evaporation, it is not occurring at a specific time or a specific temperature. I'm going to explain you shortly what is the difference between evaporation and boiling, but right now I'm telling you what is evaporation. In case of evaporation, we have a liquid at the start, and the liquid is turning into a gas, and that is called as evaporation. In evaporation, it is a heating process as well. That's why it is a plus triangle process. So a liquid is turning into a gas in case of evaporation. Okay, there are two other processes part of your syllabus. Right now one of them is in front of you, that is called sublimation. Opposite of sublimation is there as well, and that is called as deposition. In case of sublimation, basically a solid is turning into a gas directly. Yes, there is no liquid state in case of sublimation, and there is no liquid state in case of deposition as well. So from a solid to a gas is called as sublimation, whereas from a gas to deposited, so particles of the gas are deposited in case of deposition. As a result, a gas is turning into a solid. We can say this thing that sublimation is a heating process, whereas deposition is a cooling process. So whenever we should know this thing, whenever there is a change from solid to liquid, it means heat is added. From liquid to gas, heat is added, whereas reverse is the heat loss processes. Okay guys, there is a one square and one circle. There are 6 processes over here. So one of them is melting, reverse of melting is freezing, one of them is boiling, reverse of boiling is condensation, one of them is sublimation, reverse of sublimation is deposition. Whereas evaporation, yes, evaporation is a different process. I'm going to explain about evaporation very shortly. Okay. So here right now we are going to study melting in detail. Melting is there in front of you, the graph, the curve. It can be called as the graph of melting or the curve of melting. Guys, melting is a heating process. So this curve, this graph is a heating curve, is a heating process. You can see this thing that a solid is converting into the liquid state. We are adding heat into it. So that's why graph is moving upward. Guys, there is a hint for this. If a graph is moving upward, it is a graph or a curve for a heating process. If a graph or a curve is moving downward, then it will be considered for the cooling process. You can see this thing that a solid is there at the A state, and when heat is provided to that A state solid, there is a transitional state. The T dot S is the transitional state that is written with the graph as well. Transitional state. What is transitional state? A transitional state is basically a state changing area. It is an area, it is a duration, it is a time in which heat is provided to that substance and the forces of attractions are broken, or forces of attractions are going to be formed in this process. What is transitional state? I'm going to explain that again. Guys, transitional state is basically involved in both heating processes and in cooling processes as well. In heating processes, when we are talking about the transition state, all the heat energy is provided in the heating process, and that heat energy is used to break up the force of attraction among the particles of the solid, among the particles of the liquid, and then the next state is achieved. So you should know this thing that in the transitional state of heating process, heat energy is breaking the force of attractions, whereas in the transition state of cooling process, heat energy is removed, so force of attractions are going to be developed. In the heating process transition state, force of attractions are broken, whereas in the transition state of the cooling process, force of attractions are developed. Okay, this is the difference between the two. This should be very clear. Guys, you can see this thing that in the transition state, the time is changing approximately from 30 minutes to 60 minutes. It is very important to write that what is on the x-axis, that is the time, that is the independent variable, and it is with the units of minutes, whereas on the y-axis, this is the temperature, which is with the unit of degree centigrade. And by increasing the temperature, we can say this thing that kinetic energy is increasing as well. So when we will increase the temperature, kinetic energy will be increased. Hence in this way we can say this thing, kinetic energy will be written in the units of kilojoules per mole. So when we will increase the temperature, energy will be increased as well. Okay, we can see this thing that initially it is a solid. When we have provided the heat energy to the solid, it is reached the era of the transitional state, and when transitional state is reached, it is further heated, and finally transitional state is changing into the liquid state. Okay, into the liquid state it is changing. Okay, and that is called as the heating process. That is called as the heating process. Okay, so this is what happening in case of in case of melting. When we are talking about the freezing, we can say this thing that in the freezing, basically a liquid is changing into the solid. A liquid is changing into the solid in case of freezing. So basically we have the liquid initially. When we are removing the heat energy from that liquid, it is changing into the solid in case of freezing. We can say this thing, it is a graph which is moving downward. Why this graph is moving downward? Because this is a cooling curve, this is a cooling process, that's why its graph is moving downward. Guys, there is a change over there as well. There is a T dot S called transitional state over there. You people should write transitional state in the graph. In the transition state from B to C, you can see this thing that time is changing, time is increasing in the x-axis, but even then there is no change in the temperature. Why there is no change in the temperature? Because all the heat energy removed, all the heat energy lost is used to develop the forces of attractions here in case of freezing. That's why in case of freezing, basically we can say this thing that in the transitional state no more change is happening. There is a straight line over there. You can compare the straight lines of both the graphs here and can see this thing that these transitional states are not changing in the graph. There is a straight line and the time is increasing. So what is happening in the heating process? Force of attractions are broken. And what is happening in the cooling process? Forces of attractions are developing. Okay. Right now, again, there is a boiling process. Boiling is also a heating process. A liquid is changing into a gas, so it's a heating process. We can see from the graph that as it is a heating process, so graph is moving upward. And at the A, there is a liquid state. From B to C, there is a transitional state. And from C to D, there is a gas state. We can see this thing that in the transitional state, basically, forces of attractions are going to be broken in case of liquid. So one should know this thing that in the transitional state of boiling, basically it's a heating process, and just like melting, forces of attractions are breaking here. Okay guys, now I'm taking you to the major difference between evaporation and boiling. You should know this thing that in case of boiling, basically basically we are saying that a liquid is turning into a gas at the boiling point. So boiling point is a fixed temperature. Guys, what is the boiling point of water? H2O is the formula of water, whereas water's boiling point is 100 degrees Celsius. So it is 100 degrees Celsius whether you are in New York, Dubai, or in Pakistan. So it will be remain same. Okay, so remember this thing that when we are talking about boiling point and evaporation, boiling and evaporation, there are few differences between the two. In evaporation, we are washing our clothes in summers and in winters as well. We are spreading those clothes under the sun, and we are observing this thing that clothes are getting dried earlier in case of summers, where they are taking longer interval of time in case of winters. What is this procedure happening? We know this thing that in case of evaporation, basically a liquid turns into the gas before boiling point, whereas in boiling a liquid turns into a gas at the boiling point. Guys, keep this difference of before and at in your mind very clearly. Here I am going to compare between evaporation and boiling. In evaporation, we can say this thing at the surface of the liquid, it is happening at the surface of the liquid. Bottom particles are not evaporating, rather the surface particles are evaporating. Guys, what is happening in evaporation basically? Okay, details of evaporation are related to the vapor pressure and etc will be taught to you in AS chemistry, but right now I am just telling you that in case of evaporation, you should know this thing that energy is gained, kinetic energy is gained by the particles of the liquid. When there are the particles of the air, they are hitting the surface particles of the liquid. As a result, particles of the surface are gaining the energy, and then they are leaving the liquid and converting themselves into the gas state. Okay, so obviously the bottom particles of the liquid cannot gain that energy from the air because they are covered, they are loaded by lots of the particles of liquid at their top. So hence in this way, the top liquids of the top liquid particles are gaining the kinetic energy from the particles of the air. As a result, they are converting themselves into the gas, right? Okay, and we can say that in case of boiling, it is happening in the through throughout amount of the liquid. For example, just consider a liquid in a container and we are boiling that water for a tea, for example. We can say this thing that boiling is not happening at the top, it is not happening at the bottom, it's not happening on the walls, rather it is happening throughout the amount of the liquid. Okay, so in case of evaporation, the difference number 2 is it is affected by the external temperature. So if external temperature will be higher, evaporation rate will be higher, evaporation speed will be higher. Speed and rate will be considered as the same words in case of chemistry. So we can say this thing that speed will be higher in case of evaporation if we will increase the temperature, but rate of boiling will be unaffected by the temperature. In the month of June, the boiling point of water is 100 degrees Celsius. In case of January, the boiling point of water will be remain 100 degrees Celsius. Whereas in case of evaporation, we can say this thing that in June, evaporation rate will be higher, whereas in January, evaporation speed will be lower. Okay, we can talk about evaporation further. The third difference can occur at any temperature before boiling point of the liquid. So we can say this thing that for example, let's consider water. I'm just giving you the example of water again and again because it is one of the very easily available liquid, and lots of information are already very clear about that. We know this thing that water is one of the liquid of which 3 states are very clear. We know that we are drinking water in the liquid state. Ice is basically the solid state of water, whereas steam is the gaseous state of water. Okay, so these 3 states are in front of you. You can see this thing that we are boiling water, and water's boiling point will be remain 100 degrees Celsius. It will be never 99 degrees Celsius. Okay, so in case of evaporation, it can occur at any temperature. At 30 degrees centigrade, water will evaporate. At 10 degrees centigrade, water will evaporate. At 90 degrees centigrade, water will evaporate. No doubt, at 90 degrees centigrade, the rate of evaporation will be much higher as compared to the 30 degrees centigrade. Okay, but in case of boiling, it is occurring at only a boiling point. Okay, now we are going to explain about sublimation and deposition. Guys, we have explained about sublimation and deposition. I mean to say, we now know this thing that what is sublimation. It is a change from a solid to a gas, whereas deposition is opposite to that. There are 4 examples of the substances which can show both sublimation and deposition. Number 1 is ammonium chloride. Ammonium chloride, the formula is written here. You people have to keep this formula in mind. And what is the formula? NH4Cl. Whereas number 2 is solid iodine. It is I2. Then number 3 is dry ice. That is called as solid carbon dioxide formula. Solid carbon dioxide should be in your mind. I mean to say CO2, and then S is the state of matter. I am going to explain these 4 states of matter as well. 3 are the common which we have used, and 1 is called aqueous, when something is with water, and I will tell you how to write the states of matter as well. Then the 4th is naphthalene. Formula of naphthalene is not part of your syllabus. It will be taught to you when you people will be in A2 chemistry. But right now I'm telling you the naphthalene is a scientific term, it's a scientific name for the mothballs. You people might have seen the mothballs which we are keeping in the clothes for the safety purposes, etc. Well, right now I'm telling you that all these 4 examples are in the category of sublimation, and they are in the category of deposition as well. Okay, here there is a very clear diagram. I have tried to draw this diagram to explain you guys. There is an inverted funnel. You people have seen a funnel, and I'm going to draw the funnel again here so that you people may not forget. This is a funnel. This is a funnel I am drawing here. Okay, and that is also called as a filter funnel. If we are talking very exactly, it is also called as a filter funnel. It is a inverted filter funnel, and there is a cotton plug at the top of it. Why there is a cotton plug at the top of it? So that the vapors of the substance may not go out. You can see this thing that the solid in the state of balls is taken in a china dish. The container, which is just like a bowl type of thing, it is called as china dish. It is made up of a specific clay called china clay. That's why it is called as china dish, and it is placed on a tripod stand. It is a three-legged stand. We cannot have a look at the third leg. It is behind the scene, you may consider, but it is called as a tripod stand. And there is a Bunsen burner. Labeling is really very important regarding paper number 4, that is called as ATB paper. And this solid is turning into a gas. You can see the vapors, and then gas is turning itself back into the solid. The solid flakes are depositing in the inner surface of that filter funnel. So from solid to gas, that is called as sublimation, and from gas to solid, that is called as deposition. So this is happening basically in case of sublimation and deposition. So you can consider this thing that sublimation is a heating process because solid is changing into a gas, and then deposition is a cooling process because gas is changing back into the solid state. Okay, we know now this thing that the surface of the inner surface of the filter funnel is comparatively at a lower temperature as compared to the china dish. So when these vapors of when this gas state of this solid is touching the colder part, so it is turning into the solid again. Okay, so from solid to gas, sublimation, and from gas to solid is the deposition. Is that clear, guys? So I have explained you about all three states of matter. We have discussed this thing that what is kinetic particle theory. We have discussed this thing that how we can convert one state of a matter into another state of matter. We have discussed the different graphs, heating and the cooling graphs as well. Right now I am going to tell you what are the different three states of matter, the symbols, state symbols, not three, rather four. Here I am telling you 4 states symbol. So it is the solid, which will be in this case, and then it is a liquid, which is here. This is in the gas state. This is AQ, stands for aqueous. And what is in the solid state means solid state generally the liquid, for example liquid water, the gas, for example carbon dioxide is in the gas state, for example. Okay, how to write this thing? So for example, if this is like this solid, it means that it is, we are talking about the ice right now. For example, it is this liquid, it means that we are talking about water at room temperature. And what is the room temperature? 25 degrees centigrade. Guys, in many questions might be you will see this like this, room temperature pressure. So what is room temperature pressure? It is 25 degrees centigrade temperature, and the pressure is 1 atmospheric pressure, which is 1 to 2 atmospheric pressure on which we are existing right now. But guys, it is not affecting the question. But sometimes they are saying this thing that water is below room temperature pressure, or you may say it is at that, they will mention this thing that at 100 degrees Celsius, it means that water will be in the gas state, because we know this thing that water's boiling point is 100 degrees centigrade. Might be from this statements any of the student can get this idea that might be we have to memorize the boiling points and melting points of different substances. No, a big no. You people have to keep the melting point and boiling point of water in your mind, and that is 0 degree centigrade is the melting point, whereas 100 degrees Celsius is the boiling point. One more thing which I will suggest you, no doubt there is no need for it, but it will be helpful to you. And what is that? That is NaCl, sodium chloride. NaCl is the formula. Sodium chloride is the formula of our table salt. From now onward, you people are not going to consider it as a table salt. You people will keep the term of sodium chloride and NaCl formula in your mind. I will tell you how to write the formula and the name, etc. But over there I will tell you that it is I'm telling it right now, brother, it is NaCl, and its melting point is 801 degree centigrade, whereas its boiling point is 1400 degree centigrade. Okay, so this information will just help you in recognizing few of the questions regarding MCQ or giving some of the information. By the way, it is not compulsory to keep that melting points and boiling points of sodium chloride in your mind as well. Okay, it's not very important, but sometimes it can be helpful. I'm telling you, for example, only sodium metal has a melting point of 98 degrees centigrade. Okay, so such type of informations can be helpful to you when I'm going to solve the past papers with you, then things can become easier. But for example, if we are talking like water is in the gas state, okay, so it means that it is in the steam form. So this is the state symbol which I have written here. When we are talking about the aqueous state, for example, we are saying that it is NaCl and we are writing aqueous over there. It means that NaCl is dissolved in water. Aqua mean water is there. Aqueous means it is dissolved in water. That substance is dissolved in water. That substance has water along with this. Okay, so this is the information which was related to today's lecture. In the next lecture, inshallah, we are going to study about diffusion. Okay, that is the second part of this chapter, and after diffusion, all the first chapter explanations will be finished, inshallah. Thank you very much, guys. See you all in the next class, inshallah. Wishing you all the best for your exam preparation. Thank you very much, and I will be very happy to see your questions in the comment section. Thank you. Allah Hafiz.